Number 24, catapulting mushrooms. Certain mushrooms launch their spores by a catapult mechanism, as water condenses from the air onto a spore that is attached to the mushroom. A drop grows on one side of the spore and a film grows on the other side. The spore is bent over by the drop's weight, but when the film reaches the drop's water suddenly spreads into the film, and the spore springs upward so rapidly that it is slung off into the air. Typically, the spore reaches a speed of 1.6 meters per second in a 5 micrometers launch. Its speed is then reduced to zero in 1 millimeter by the air. Using those data and assuming constant accelerations, find the accelerations in terms of g during the launch and the speed reduction. So what we have here is just acceleration of a particle, and we have constant acceleration. So we are assuming that the acceleration is constant. And if the acceleration is constant, there is three different equations that we can use, which are x equals to x0 plus v0t plus at squared over 2. We have also v equals to v0 plus a times t, and we have v squared equals to v0 squared plus 2 times a delta x. So those are the three equations that we have when the acceleration is constant, and only when the acceleration is constant. If the acceleration is not constant, you cannot use those equations over there. But in this case, we can. So we will use this equation over here to solve our problems, because we have the initial velocity, the final velocity, and the distance that the particle traveled. So let's go. Letter A. In letter A, we have that the initial velocity is 0. We have that the final velocity is 1.6 meters per second. And we have that delta x equals to 5 times 10 to the minus 6. Why minus 6? Because this letter over here, mu, equals to 10 to the minus 6 meters. So we want to find the acceleration over here. So we just have to isolate a in this equation, which would lead us to a equals to v squared minus v0 squared over 2 delta x. So replacing this, we have 1.6 minus 0 over 2, 5 times 10 to the minus 6. And this gives us, let's see, 2.56 times 10 to the 5 meters per second square. But this is not the final answer, because the exercise wants us to find in terms of g. So how many g's are these? 1g equals to 9.8 meters per second square. How many g's we have here? So we just have to divide here. We just have to do 2.56 times 10 to the 5 over 9.8, and we get 2.6 times 10 to the 4th g's. This is the answer. Letter B. In letter B, we have that the initial velocity is this velocity, the initial velocity v0 is this velocity over here, 1.6 meters per second. And then the velocity goes to 0, so the final velocity equals to 0. And delta x, in this case, would be 1 millimeters, or 1 times 10 to the minus 3 meters. We will use the same equation, so the acceleration would be v squared minus v0 squared over 2 times delta x, which would be 0 minus 1.6 squared over 2 times 1 times 10 to the minus 3. This is equal to minus 1.28 times 10 to the third meters per second square. And again, we have to divide by 9.8 or 9.81. It depends on the precision that you want. And then we have the acceleration would be minus 1.3 times 10 to the second g's. So this is the answer of this exercise 24.